My name is George Eliseos, and I'm a director of product management here at AWS, leading some of our hybrid and edge computing products. And I'm particularly excited about our time today here because I get to talk about something that our team and I are really passionate about. And that's how AWS continuously pushes the boundary of what we are thinking of as the cloud, and really extends the definition of the AWS platform and breadth to encompass the various types of hybrid and edge deployments. And of course, talk about how AWS continuously brings the cloud closer to where customers need it. But let's start with some of the fundamentals. When we talk about hybrid or the edge, we're really talking about a multitude of things. Different types of notions of what edge is, different types of edges, and what they're used for. I've heard it really being used in hundreds of ways and contexts over the year. But one key misconception that we keep running into is that there are two separate silos that strongly separate the cloud and the edge, as if there is one centralized cloud, and then there is a completely different fabric that comprises the edge, as if there are two different types of models of application development or deployment that are really strongly separated between them. But as we continued over the year building services and features in this area, we found that really this is a misconception, and this is not truly how things work. We did what we always do in AWS. We spent countless hours talking and listening to our customers very closely. And what we kept hearing was that customers want the same AWS that they know and love, but closer to where they are, where their end users or their other deployments are. We also have continuously found that there are use cases either driven by low latency applications, migrations and modernizations, or even that need to satisfy data residency requirements that require really more cloud in more places. And predominantly what we heard was that the solutions that adhere to this legacy thinking, this legacy siloed thinking of the cloud and the edge really doesn't work for customers. It's too complex, it's too costly, it requires too much maintenance, and it's very difficult to own long term. Why is that? Well, because it requires you to maintain different environments, train engineers across different solutions, adhere to the lowest denominator of features across solutions, and even own infrastructure and hardware with all of the work that that brings with it. As we, there we go. As we dove into this feedback, what became obvious is that customer applications really lie on a spectrum, and a continuous spectrum, let's say the application continuum, rather than those two silos that the thinking was suggesting. When looking at this continuum, you can see that most applications can very easily be migrated to the cloud, and they have driven that massive cloud adoption that we've seen over the last years. These are web and enterprise applications and so on. But then you have applications that are a little bit harder to migrate to the cloud, either because they need to be re-architected or upgraded or remade in order to be lifted and shifted into the cloud. This could be due to latency, local data processing, data residency requirement, or other reasons. And then you have those types of applications that will remain on premises for the foreseeable future for those same reasons. Maybe they need sub-millisecond latency to an existing system, like a manufacturing line. Or maybe they are forced to be in a particular data center to adhere to data regulations. And this on-premises could be anything, really, from data centers to branch offices, manufacturing plants, the 5G network itself, restaurants, and so on. But in addition to these existing applications, what we've also found was that there are a few emerging trends. One of those trends is the need for extremely low latency. There is an emerging set of applications like AR, VR, game and live video streaming, autonomous vehicles, engineering simulations, data inference at the machine inference at the edge that require really ultra-low latencies. Or we have another set of applications that really need to process data locally, as customers continue to create and amass vast amounts of data by their digitizations of their environments like factories and branch offices or by IoT solutions, many times this set of data is harder to migrate to the cloud because of their sheer size, either because of size, bandwidth, or even timing limitations. They have to be processed locally, right where they are produced. And of course, finally, you have data residency, driven by security and tax regulations, by data sovereignty, and by the changing geopolitical environment. Sometimes customers need to store and process data in a particular country, state, municipality, or even particular data center. So really what customers want is to build applications that are not siloed. They want solutions that extend the same tools and services that they already know and love to wherever they need them. But latency-sensitive or data-centric parts of the applications can be distributed close to the end users, while the larger non-latency-sensitive parts of the applications can be run in a more centralized location, like the AWS region, for example. So we also see customers building in this hub-and-spoke model, where they distribute, let's say, the inference part of their machine learning application to the edge, but do all the training in a more centralized location, like the AWS region. What customers really want is for the cloud to extend in a way that addresses their application continuum. And a key request that we have found over these years when we hear customers talking about this is that they want a sameness. Regardless of where their applications need to reside, customers want to use those same toolings. They want to use the same infrastructure, they want to use the same services, the same APIs and models. And it's not just about the hardware or the deployment model. It's everything down from the infrastructure up to the API level and everything in between that customers want a consistent experience on. So really what we are saying here is that customers want a continuum of consistent cloud services in order to match that continuum of applications that we discussed before. So the AWS response to that has been twofold. First, we continue to aggressively expand our global infrastructure with 84 availability zones across 26 regions globally, and with hundreds of points of presence that serve direct connect or CloudFront CDN locations, but also with our global redundant 100 gigabps backbone that circles the globe with transoceanic cables, and allows customers to do much more on the AWS platform than ever before in many more places than ever before. And while we continue to aggressively expand our global infrastructure, we've also worked on a second way of enabling customers, which is equally important, really. Over the last few years, we've seen the launch of services like AWS Local Zones and AWS Wavelength that really take the traditional AWS region and expand it into places like major metropolitan or industrial centers, the 5G network itself, or the customer on premises, whatever that may be, with AWS Outposts, and even create an unbroken chain from the cloud all the way to the device through the IoT services on AWS, really bringing the cloud and the far edge together. And of course, extending even to the disconnected or rugged edge with the AWS Snow Family in locations where connectivity may not be available or the environment may be even hostile. And when you take a look at the variety and breadth of applications that these types of offerings enable, it is really clear that they're really giving the customers what they really need in a much more meaningful and significant way than that siloed approach of cloud and edge. And we've been delighted by what customers have been able to build on these solutions and services. Everything from health and life science management systems that need to remain on premises in order to process images in low latency or adhere to data regulations, data residency regulations. For media and entertainment customers, and the gaming community, enabling graphics processing and audio and video rendering and even streaming. And for banking and payment systems for financial customers, really it is really virtually impossible to comprehensively list all the things that customers are doing with these services. But why don't we try to dive at least into some concrete examples of what customers are doing and how AWS Hybrid and Edge services enable various use cases for customers. Let's start, for example, with extending the cloud to metropolitan industrial centers. How does that help customers? Let's say we have a customer in Houston or an enterprise that has offices in Phoenix, in Arizona. Today, these end users are being served well enough from the 4 US AWS regions. However, depending on the path that the traffic takes from the application that's hosted in the regions to the end user, the latency can grow from tens to even more, to even hundreds of milliseconds at cases, depending on the internet traffic and the exact place where the user is and the application resides. To help these customers really drive down this latency, but also create a more predictable experience for the end customers with lower jitter and predictable latency, we've launched what we call AWS Local Zones. Local Zones really extend the AWS region to a geography which is different than when the region originally resided. And by extending that region, they allow the customers to extend their own applications to that different geography. And of course, by being an extension to the AWS cloud and the AWS region, they also allow customers to use the same APIs, the same tools, the same partner solutions, and the same stack all the way from the hardware up to the services that they use and they love already in the region. You can even use the same EC2 instances on the same hardware on a local zone that you use in an AWS region today. So coming back to that customer that is in Houston, instead of connecting their users to an application that's running in the Northern Virginia region, let's say, they can now extend their application into Houston and have their users locally connect, providing latencies down to single-digit milliseconds. And of course, it's not just Houston and Phoenix. We started with a single local zone in Los Angeles, and we've grown to 16 local zones generally available in the US today. These were based on customer inputs, but also an analysis of the latency coverage that we needed to have in the United States. With this local zone, customers can now offer very low latency to a particular location, hyper-locally, where their end users are, but they can also build these distributed cloud applications in order to serve a geographically distributed end user base. Why don't we dive into some specific examples of how customers are using the AWS local zones and see how they enable them to tackle different use cases, though. I want to start with a case study that is that hyper-local variety, where a customer needs to really provide a solution very hyper-local to a specific location. One of those is the low latency to power online workstations. Up to today, to create those stunning visual effects and animations that we see in movies and films, FX artists needed to really employ all of their specialized software and assets like videos and files that span petabytes of storage in specific offices, in studio offices. But imagine that any part of your work you have to go into the office. That's clearly not a 21st century solution, and the global pandemic, the COVID-19 pandemic, has really put a magnifying glass to that problem. What Netflix have done is they've moved their artist workstations to the cloud in the Los Angeles local zone. They then established a direct connection between that local zone to their animation hub in Los Angeles, creating a single millisecond latency between all of their video and image assets to the workstations themselves. That allows artists to now work from home or from a cafe or from wherever they want, while still having the same work experience by accessing their workstation in the cloud and the workstation accessing their assets in the Netflix data center with very low latency. It really increases the agility of Netflix, and it frees their artists from having to go to the office to do their work. A second use case that I want to highlight is that of an enterprise migration. This is yet another locality-based use case and showcases how the journey from on-premises to the cloud is getting eased by the services that we provide in the hybrid and edge space. Enterprises like MindBody have workloads running their existing on-premises that they have evolved over the years or even acquired over the years. MindBody and many customers like them tell us that these applications create a complex interdependency between the different modules and different applications that they run that really are very hard to migrate to the cloud. They really present that boil the ocean problem where you either need to lift and shift your whole on-premises deployment into the cloud, or you really need to go re-architect and untangle that interdependency to start moving parts of the applications over. The solution here is to really extend the cloud so close to your data center that the difference is imperceptible. It's like having your cloud so close that you can start moving parts of your application onto the cloud, and those parts of the application can still talk to the rest of your on-premises deployment with such low latency that's imperceptible to the application performance. MindBody, for example, have used their closest local zone to establish a hybrid environment between their on-premises data center and the local zone. That allowed them to start migrating parts of their applications and workloads over and not having that boil the ocean problem, really easing their migration into the cloud long term. Then you have customer case studies that are good examples of what we think of these geographically distributed use cases. These are customers that need to address multiple users across different geographies. And it's particularly relevant for industries like real-time multiplayer gaming and streaming, where Supercell is a great example of customers making a difference. The problem really here is that in order to provide a really good gaming experience, you need a latency between the application, the game server, and the end user that's lower than 30 or even 20 milliseconds. Anything more than that degrades the online experience for gamers. But in order to achieve that, customers like Supercell and other gaming customers really need to have multiple deployments on multiple on-prem facilities across the world or across the country. But maintaining multiple on-prem facilities is really hard and slows you down. You have to take care of everything from hardware breaking, on-premises or colo contracts, renewals, and expansions. You have to take care of upgrades, not to mention the whole software management layer nightmare that you can find yourself into. So what companies like Supercell do is they leverage local zones to actually get rid of all of that. They can extend their application from one location in the region to multiple local zones and address those latency requirements of their end users while maintaining a very consistent experience of their own developers on how they build, deploy, manage, and scale applications. It's a very repeatable and flexible and scalable model that allows customers to really meet those latency requirements and expand and contract in a very cloudy way. And as I've been suggesting all this time, these customers can really leverage the same services that they use in the region. Basic services like EC2 and EBS and VPC and FSX and others with a variety of instance types and storage options. Container services like Amazon ECS and Amazon EKS, databases, in-memory caching, big data solutions with RDS, Elasticas, and EMR. And even like simple networking, like connecting to your hybrid environment to the cloud with Direct Connect. And of course, you get to leverage all of the helpful management and monitoring tools like autoscaling, CloudTrail, CloudWatch, and so on that the AWS platform provides you. Going from 1 to 16 local zones in the US has been quite a ride, but building on that success that we've had in the US, we have now announced 32 new local zones globally. These are growing to countries all over the world, from North America with Vancouver and Toronto, to South America with Santiago de Chile and Buenos Aires, places in Europe where we didn't have AWS before, like Amsterdam and Athens, Africa with Nairobi and Johannesburg, And of course, APAC with Auckland, Bagong, Manila, and many more. So we've talked about extending the cloud to the metropolitan areas, but let's continue our journey to the different ways that the AWS cloud is getting extended. On-premises is a very obvious area and a space where really that old thinking of cloud versus on-premises is being shattered. Let's say I'm a customer that really needs to keep some applications in their data center, either for data locality or for latencies below 1 millisecond to on-premises deployments, like, for example, an automated manufacturing line. If there is no AWS right there where I need it, or if that latency needs to really be sub-milliseconds, and we're talking about nanoseconds, really, I don't have a choice but to deploy something within my data center. What comes into play here is the AWS Outposts family of products. Outposts is a family of managed solutions that deliver AWS infrastructure and services to virtually any on-premises facility or data center. They follow the exact same model of the AWS Local Zones that we discussed before, of extending that region and the AWS cloud, but this time in your customer data center or your on-premises facility. Outposts are available in many different form factors, starting from 1U servers and 2U servers, all the way up to a full 42U rack, which, of course, you can cluster together for multi-rack deployments. And they are available in multiple countries across the world. We're already in 65 countries, and we'll continue expanding. For those customers that really need to run VMware workloads on premises, we have VMware Cloud on top of AWS Outposts. That's a joint engineering solution between VMware and AWS, and brings enterprise-grade features of the VMware Cloud, like the software-defined data center, running on that managed experience that AWS provides on top of bare metal servers, on top of the Outpost product that leverage that AWS Nitro system and really extend the AWS cloud. This allows you to deploy now your VMware on AWS workload right next to your VMware on-prem workload, making things easier and simple to transition between each other. Outposts really give you a lot of flexibility on constructing and architecting that hybrid environment of yours. So what does the Outpost rack look like? Well, it comes in a 42U rack form factor. It's fully assembled and ready to be rolled into the position. You can go to your AWS management console, create your Outpost deployment, choose things like your capacity and, of course, your location you want it to be delivered at, and then AWS associates show up to your data center, roll the rack in, plug it to power, and to networking, and the rack self-provisions itself. It comes with a centralized redundant power distribution for DC distribution, and also has many redundant active components like switches, and even spare capacity to increase your availability of applications that run on the Outpost. And of course, you can create multiple Outposts within your data center to further boost that availability, or even place Outposts across different data centers. Let's dive into a couple of examples of how customers are using Outposts. I wanted to start with Morningstar, who is a customer that is on a multi-year journey to adopt AWS for 100% of their workload. Their end customers really expect very low latency for the real-time investment, insights, and research. So Morningstar are leveraging Outposts to avoid the overhead associated with managing, monitoring, and delivering a hybrid on-prem solution across cloud and on-premises. That way, they are massively accelerating the way that their own engineering force across their teams can adopt modern technologies like the AWS cloud. And not only they are accelerating that adoption, every one of their new deployments, whether it is a lift and shift of an existing application from their on-prem deployment into the Outpost, or a new application that they are developing, is very easy to eventually move into the AWS region because the Outpost is that extension of the region. So they're really future-proofing themselves. But what if I am a customer that really needs to be in a specific jurisdiction where there is no AWS presence, let's say? FanDuel Group is it's a leading sports gaming company in the US, and it's a good example of that. What FanDuel have done is they have accelerated their expansion in the US by leveraging the Outpost product. Basically, what FanDuel needs is the need to have local deployments in various US states where they need to expand into. But instead of creating, designing, and deploying customized deployments for every one of those states, what FanDuel have done is they've leveraged the power of Outposts to create a cookie cutter approach. They have a stack that they can now take and deploy into a new state, a new country, or wherever they want to be within less than 3 weeks versus the more than 4 months that was their deployment approach before. This allows them to quickly deploy production-ready instances of their platform in specific approved locations in a predictable, fast, and effective model rather than trying to create a different deployment in each one of these areas that they want to be in. And of course, you also have customers addressing these geographically distributed use cases that require distributed cloud implementation with Outposts. Riot are a great example of that. They wanted to quickly support the launch of the latest game, Valorant, in places where there was no AWS presence before. They needed to do that, again, to provide that consistent low latency to the end gamers that we discussed before. However, with the lack of AWS in a particular place, what they did is they deployed their Outposts across 3 countries in multiple locations to extend their game servers in those locations and meet those latency requirements. So if you think about that Riot use case, Outposts really can allow customers to expand the AWS cloud wherever they want it, in any type of on-premises facility or even a data center or even non-data center facility. And of course, it goes back again to that sameness we've been talking about. Not only you get that same API experience in order to provision and manage your Outposts, but you get the fully blown services like Amazon RDS and EBS and ECS and EMR on top of your Outposts. Again, so on as before. It's that sameness that we've been discussing and that customers have been asking us about. Extend the cloud, do not create a copy of it, but extend the real cloud into the different locations, allowing for no drift to happen between deployments and providing my engineering force with the same experience and the predictable and fast model. We saw the Outpost Rack before, but Outpost also comes in a server form factor. While a rack is great for a data center application, for a highly distributed environment that requires less compute but in more locations, Outpost racks are really handy. You can rack mount, Outpost servers are really handy, sorry. You can rack mount those servers into existing racks that host anything from other servers to switches or other networking equipment. And each server has a much lower power draw and requires lower bandwidth than the whole rack. So we've seen customers really leverage these servers to tackle applications, everything from retail stores or branch offices for point-of-sale systems, security monitoring, smart displays, and so on. Healthcare providers that have a range of hospital or smaller clinics and really need to do a lot of local data processing of patient images and other medical records. And of course, factories and distribution centers that are getting modernized and that need local data processing in order to integrate with monitor systems, IoT solutions, and so on. So we've seen now how the cloud extends to metros. We've seen how the cloud extends to virtually any on-premise facilities. But let's continue our journey with how the cloud can be extended into the 5G network. This is an area where AWS is really breaking ground. With AWS Wavelength, customers can deploy their AWS applications within a telco 5G network and leverage that power of that transforming technology that 5G brings. You see, when a mobile phone needs to reach an application running on the AWS cloud, really needs to reach through the telco provider network, out through the transit point, over the internet, and reach the application that's running on the AWS region, let's say, a gaming or a VR application. That can result in dozens or even more milliseconds of latency and degrade the experience. This is because of the multiple hops and the additional network traffic that the application needs to go through. What AWS Wavelength does is extends the AWS region now within the 5G network. It's like a local zone, but instead of being in a metro area, it's within the actual 5G network itself. That allows the application to be extended in the network, and now the traffic from the mobile phone or other mobile device doesn't need to travel through that path. It can reach the wavelength zone and the application running on it directly into the network. Since the network path traverse is much shorter, the quality of service is highly controlled by the telco provider, and you get much lower latency, much lower jitter, and a much more controlled experience. And of course, because that link between the application and the mobile phone is fully controlled, we can start thinking about doing some other newer, cooler things. Like, for example, being more prescriptive about what the exact quality of service of a particular application is that runs on the 5G network, or provide information about the network parameters, or even about device capabilities and location. And we're seeing customers really leveraging these technologies already. We're seeing, for example, customers like here that help vehicles detect obstacles ahead and distribute a number of targeted messages to road users. For example, let's say a pedestrian crosses the street. Not only will an oncoming driver get a message alert, but also other traffic around and behind that driver will get customized messages that the vehicle in front of them is about to brake. To accomplish such a thing, a lot of the processing needs to happen there hyperlocally. All the data needs to be acquired, stored, and processed locally. Can't afford to go into a long road trip to the AWS region or wherever the application could be running. AWS is working with the Verizon business group for edge solutions and with the HERE team to build that platform within AWS Wavelength so that all of the processing happens locally, all the relevant information is processed and distributed via intelligent messages to all of the road users that are in that area. And then you have customers like CrowdVision, who is a pioneer in video analytics. They offer both video and LiDAR solutions to better manage public spaces and improve crowd management under various situations. The common problem that they see is that they need to deploy hundreds of devices in order to manage these crowds and to get really the information from the LiDAR sensors and the cameras. However, deploying these devices and wiring them up is actually really hard and not very dynamic. You need to run cables anywhere, and every time you need to make a change, you need a crew to go there and make changes into the cabling and so on. So what they really got CrowdVision are trying to do is leverage that 5G network to connect all of their devices through 5G technology and have all of the processing that helps them recognize the crowds and manage and provide insights and management of the crowd solution there locally. The other really important thing to note here is that by acquiring that agility through AWS Wavelength, CrowdVision are free to start thinking about how to expand in different applications in different areas, like, for example, security screening at airports or at big venues, something that they weren't thinking before. And we are seeing more and more of customers really embracing 5G technology and integrating it into their model. And whenever we do, we see always edge computing coming hand in hand. AWS Wavelength is already in general availability in the US, in the Verizon network, in Europe, in the Vodafone network, in Korea and Japan, in SKT and KDDI networks, respectively, and it's about to launch in Canada, in the Bell Canada network. We have grown to more than 20 wavelength zones with our partners, and we continue to grow. But the best thing about AWS offerings like Wavelength and Local Zones is really that they democratize access to the edge. Anyone with an AWS account can right now log into the AWS console and launch resources into the SKT 5G network in Korea. That wasn't possible before and really powers a lot of innovation across the ecosystem of AWS customers, partners, and other members. And of course, going back to that sameness, AWS Wavelength offers very similar and familiar services like AWS Local Zones do. like Amazon EC2 with different instance types, or EKS to manage your containers, EBS to store data, and so on. And something that we didn't mention before, but is equally important, is that because these services are open to the AWS ecosystem, a lot of our partner solutions are also available in things like Outposts and Wavelength and Local Zones. You have partners like Cloudian that offer storage and disaster recovery. You have Rafe for Kubernetes container management. You have AppDynamics for a single pane of glass application management, and many, many more partners and solutions available to all of this. This is the power of extending the cloud and not creating a copy of the cloud. But let's keep going. What about reaching various IoT devices and deployments? Can the cloud really be extending as far out as the devices you own in your smart factory or your smart city? Well, the answer is yes. AWS offers a comprehensive portfolio of IoT services and solutions that help you connect and manage billions of devices. But most importantly, these AWS IoT services really seamlessly integrate with the rest of the AWS platform, smoothly extending that cloud to the device edge, to the far edge. This allows customers to build end-to-end solutions that not only collect, store, and analyze IoT data, but also secure the whole chain from the cloud all the way out to the device, and integrate with services like AI and ML. For example, you can use IoT events with services like AWS SageMaker to create model and deploy and trigger AI models depending on your IoT events. And of course, because all of this is built on the AWS infrastructure that's scalable and elastic, you can really scale your deployments to deal with billions of devices and trillions of messages at a time. A really great example of a company that does that is the Volkswagen Group. Volkswagen manufactures some of the world's most iconic brands, like Audi, Porsche, and Lamborghini. To transform their automotive manufacturing and logistics processes, the group has embarked on a journey to build the Volkswagen Industrial Cloud, which is wholly built on AWS and embeds a lot of the AWS IoT services within it. That way, the Volkswagen Group can connect data from multiple machines, plants, and systems, not only within a single plant, but across more than 120 factory sites. And by connecting all of this machinery and devices together, not only they can improve processes and fix errors within a single factory, but they can also track activity across plants, can pinpoint production losses, and share that knowledge across plants so that they can improve their logistics and their operations globally. That whole journey they've embarked on is aiming to really deliver business results by lowering the factory cost by 30% and increasing productivity by 30%. They expect to deliver more than $1 billion in logistics and supply chain savings using their industrial cloud on AWS. And of course, we continue to support customers connecting their various things and devices to the cloud with a robust set of services. You get anything from device software with services like FreeRTOS, IoT Greengrass, and the IoT Device SDK, but also going into the connectivity and control services with services like the IoT device management or the IoT core, wherever that's deployed in the cloud or at the edge. And of course, the pinnacle of it all, the analytics services that can help you really take advantage of all this data that you're managing and collecting with services like Sitewise and IoT Analytics that help customers create that flywheel of more insights that drive business results, that drive more proliferation of devices, that drive more connectivity, and so on. And really double down on extending the cloud in more and more places. So up to now, we've seen connected scenarios. All of the use cases we talked about are scenarios where the end device or the cloud is really connected between the edge and the cloud. But what happens when we have use cases that incorporate remote or even hostile environments? This is one area where customers are actually asking us for disconnected services that can operate in environments that are really changing, they're really dynamic, but they can also be hostile to them. And customers really want to run the same compute and storage services and container management services and higher level services that we've been talking about, but in a rugged format that can really survive the worst. This is where services like the AWS Snowball Edge family of products comes in. Snowball Edge comes in two formats, a compute optimized and a storage optimized format that can either let you distribute data to edge locations or even ingest data into the AWS platform from multiple locations, or even perform local processing or even build your own networks in various remote and hostile environments. Customers have really used Snowball Edge to extend the AWS cloud to unhospitable environments like oil rigs, mines, airplanes, trucks, and many more. But it doesn't really stop there. For many of the even higher distributed use cases, a rugged and smaller device is needed. Snowcon is a product that offers a sizable storage and compute with 2 CPUs and 8 terabytes of storage, but in a much more portable form factor that can withstand harsh environments and only weighs 4.5 pounds. One of the coolest things of Snowcon is that you can actually run it on battery. And so that means that you can even place it in your backpack and carry the AWS cloud around with you. It provides things like Wi-Fi connectivity, is anti-tamper resistant. So it's a really, really cool device that customers are using in multiple different ways to do really, really innovative new things. Deluxe is a company, for example, that's using Snowcon to manage their movie distribution across the world. By using Snowcon, they don't need to have server environments. They don't need to have data center environments. They don't even need to have consistent connectivity, but they can still implement a global movie distribution platform and, of course, use higher-level services like AWS Data Sync to manage that platform in a very efficient and easy way. Then you have customers like Noveta that require edge computing, but in environments that are really hostile, like disaster zones. What Noveta does is they take Snowcons and they deploy them in disaster recovery scenarios to act as IoT sensor hubs, where all of the data from the sensors and in the disaster recovery zone gets accumulated and processed so that they can track various different equipment and people in these disaster zones. Okay, so we've discussed the multiple ways that AWS extends the traditional cloud, but we also focused on traditional cloud services. If you think about it, we've been talking about compute, AI services, storage, but how about wireless networking? Can AWS bring a cloud model to wireless networks on premises? Well, one very innovative way that AWS is really pushing that boundary of the cloud into completely different types of services is by offering customers the ability to build their own private cellular networks. This is about customers really building their own private 5G network, so it's really out there. The reason this is useful is that more and more customers continue to collect and generate and amass huge amounts of data. That is driven by the proliferation of devices like IoT sensors, but even high-definition cameras that get deployed in various venues, stadiums, factories, and so on. But when you amass this data, you also need to move that data around in order to place them in a place where they can be processed, in order to collect them, and in order to derive insights from them. While wired networks provide a very good experience and high performance, a very predictable performance for customers, they are very difficult to deploy. When you're talking about devices moving around in a factory floor or forklifts living in a warehouse, it's very hard to connect all these things with wired networks. Wi-Fi comes in handy and enjoys wide adoption from customers because it's simple and it's cheap to deploy. But for these advanced use cases, like factories and large venues and stadiums, you really quickly run into the limitations of the Wi-Fi technology. You can't really cover large amounts of space. You can't really boost up the number of devices that you support without really exponentially increasing the number of access points that you have. And of course, you can't provide specific quality of service to specific devices or to specific applications. That's where 5G allows customers to connect more devices, more cost effectively, and provide all of these things. And especially when it comes to 5G networks, they offer really a step up in throughput, in bandwidth, in reduced latency, in finer control of the network itself, but also the very large amount of devices that they can support per square kilometer. Therefore, they open up use cases across various industries that may need private 5G networks. This could range from venues or stadiums with thousands of people, smart factories with thousands of devices, smart agriculture where really large open spaces need to be covered, or smart cities that combine very large spaces and thousands of devices. And so on. All of these can really benefit from 5G technology. However, building your own 5G network is not that simple. You really need to bring a multitude of technologies together. You really need to talk to multiple vendors. Many times, the pricing models involved in building a 5G network, because of the different companies that need to get involved, is not customer-friendly. It's a very new space. And customers really want the same things that they want from their cloud when it comes to their wireless networks. They want an ease of ordering and deployment. They want, after they deploy it, ease of maintenance. So they can manage the network traffic, devices, and so on. They want a scalable network that can start very small and grow. And of course, they want customer-friendly consumption models that charge you for what you use and not for the number of devices that connect to your network or provisioned bandwidth. Essentially, what customers want is a cloud model for private 5G deployments and operations, the same cloud models they have on the AWS platform today for various other services. That's why AWS introduced the AWS Private 5G service. AWS Private 5G is a completely managed service that lets customers easily build, deploy, manage, and scale their private 5G networks and connect devices and machines with low latency and high throughput. Customers with AWS Private 5G can get their own private 5G network launched within days rather than those long planning cycles, and they can do it solely from the AWS console. This service is currently on preview. We announced it at re:Invent, and it's about to be launched, generally available. With AWS Private 5G, you get everything from hassle-free procurement. You can just log into the AWS console, define your network, define your throughput, how much coverage you need, how many devices you want to add to the network, and the AWS will pull together all the hardware and software required and ship it to your location. You can start small and scale. The pricing model is extremely customer-friendly because it charges you only for the resources you use, like the throughput that you actually use, and not for things like devices that you have on your network. And of course, as all of the other things that we're discussing today, it's fully integrated with the AWS platform. So you can use things like identity and access control, not only to manage the network itself, your access points, traffic, et cetera, but even the devices that are on the network, like the SIMs that subscribe to your network. And of course, because it is a cloud service deployed in the AWS cloud, it enjoys the same pace of innovation that other cloud services enjoy. Whenever we build new features and services for AWS Private 5G, those are made available to you immediately. You don't need to update. You don't need anyone to come to your on-premise facility to do changes. So we've seen a bunch of ways that the cloud extends today. And we've seen customers that use the AWS region with one or two other products in order to simplify their deployments and really address new use cases. But there are some customers that are really revolutionizing whole industries, like telco, for example. These customers leverage a multitude of these products that we discussed today and more in order to really change the way that things are done in a whole industry and really push that cloud extension model to the max. And they really bring that vision together of how extending the cloud and not creating bad copies of the cloud all over the place is really useful for customers and pushes innovation and agility. Such a customer is This Wireless. This started with a vision to create the first really cloud-native 5G network in the world. While many telco customers have virtualized the networks before, and while many telco customers have used AWS for parts of their network or for their backend deployments, this is really reimagining how you can build a whole network. It's really reimagining the whole field. They're using AWS to deploy the vast majority of their networking across the US to build a modern cloud-native nationwide 5G network. In order to do so, AWS worked very closely with this to create alignment between how these products are used and which products are used for which parts of the network. In that way, this can scale to meet variable demand. They can reduce cost by leveraging the appropriate services for the appropriate parts of their applications. And they can build completely new services like end-to-end network slicing, which requires the cloud agility that only AWS Cloud can offer you. And of course, they can manage their thousands of locations of presence across the US from a single pane of glass, which is the AWS platform. These have leveraged things like Outposts and Local Zones to distribute part of their network, all of their network across the US. They've used the AWS region, and of course, they've leveraged the AWS backbone to push all that traffic around nationwide. So they're really an example of a customer that brings all of these services together and really pushes that vision that we've had and that we've seen in the beginning of the presentation today, where we talked about customers extending the cloud and not creating this siloed view. Just before closing, I just want to encourage everyone to visit the AWS Skill Builder that allows you to take more than 500 free digital courses and learning plans. I've taken some of them. They're great. It really allows you to expand your knowledge of AWS. And while you're at it, you can also look at the 11 AWS certifications that we offer that can also offer you an industry-recognized credential, but also connect you to other professionals in the space through the AWS certified community. I think you can use the QR codes here to directly visit those pages. Well, thank you for your time today. If there is one thing to take away is that at AWS, we really continue to believe that the edge and hybrid space is tremendously important for our customers, and that we will continue to build out in this space and find more ways to extend the real cloud to wherever the customers need it. Thanks.